Okay, so hopefully you've done these. I'm going to quickly do these so that you see your answers. First times the derivative of the second plus second times the derivative of the first. Y prime equals x cubed cosine x plus 3x squared sine x. Totally fine with that, by the way. You could see it this way. I'm totally fine with green. I'm totally fine with the green, but you could see it written in blue. Both are valid. For number 5, here's what you have to recognize for number 5 is that it's got a double chain rule, because this is really the cosine of 5x quantity squared, which means that you have your outside being your parentheses squared, your inside being cosine, and your double inside being 5x. Which makes this derivative, 2 parentheses, this derivative, negative sine, and this derivative, 5. Y prime equals 2. What was in that parenthesis to start with? Which was cosine of 5x. Negative sine, what was in that parenthesis to start with, which was 5x. And the 5. These parentheses all make a very, very big difference. So my final answer for this is 10, negative 10 cosine of 5x sine of 5x. Now, I will warn you that one of the pieces when they like to simplify, by the way, I'm good with this answer, but one of those trig identities, there are 4 trig identities you should know. You should know sine squared x plus cosine squared x equals 1. You should know 1 plus cotangent squared x equals cosecant squared x. You should know tangent squared x plus 1 equals secant squared x. You should know. Those are your Pythagorean identities, which you can get, and we'll talk about how you can remind you of how you can get them when I get back. But you should also know that sine 2x is 2 sine x cosine x. And you should know that cosine 2x is cosine squared x minus sine squared x. Those are the ones that you really should know of your trig functions from last year, your trig identities from last year. And the reason I'm mentioning that is I want to talk about this one right here. Because the reality is you could write the black as negative 5 times 2 cosine of 5x sine of 5x, which is the double angle formula for the sine of 2 of my angle. So this is negative 5 sine of 10x. Now, I don't expect you to write it that way at all, but I do expect you to recognize it because on a multiple choice answer, the black may not be there, but the blue would be there. Okay? They wouldn't both be there, but they could throw in the blue there instead of the black in the C. Do you recognize your trig functions? Alright, so the last one of these is number 6, which is x over secant x plus 1. Low GI over x1 minus I, your low over secant x is secant x, tangent x, all over the low secant x plus 1 minus x secant x tangent x over secant x plus 1 quantity squared. There are three pieces here: secant x, positive 1, and negative x, secant x, tangent x. All three do not have something in common, so you cannot factor anything out. So there's my answer. You can run your phone if you wish to. I'm okay with that. Alright. So I have 3 more to do. And again, if you want to pause them, and you can go through and you can do them on your own, or if you want to just watch me go through them, I will go through them quickly. So I'd actually ask you that you pause it for at least for about 5 minutes, so you can see what you can get done, and then come back to this. Okay, so you've paused, and hopefully you have answers here. So now let's talk. Number 7, y prime. Oop, before I do that, I'm going to rewrite this as cotangent of 2x to the 5th quantity cubed. So you can see that I have an outside of quantity cubed. I have an inside of cotangent. And I have another inside of 2x to the 5th. Chain rule. Double chain rule. So my derivative of my outside is 3 parentheses squared. The derivative of the inside, so the cotangent, is negative cosecant squared. And derivative of the other inside is 10x squared. All of these are going together. So y prime. 3, big parentheses squared, parentheses, negative cosecant squared, parentheses, little parentheses, and then 10x. Please note that all 3 pieces are in parentheses, because it's all multiplication. If you don't, this middle section that has a negative, you're thinking, I think it's subtraction. That's not. It's multiplication. What goes in this first parentheses, which was what was there first, which was cotangent. You're right today. Cotangent of 2x to the 5th. What goes in this parentheses, which was what was in cotangent to start with, which was 2x to the 5th. So now I'm just going to simplify and combine the terms. What I can combine is the 3, the negative, and the 10x squared. Y prime is negative 30x squared. Cotangent squared of 2x to the 5th. That was from here. I just put it on there. It doesn't matter either way. That's your choice. Cosecant squared of 2x to the 5th. I just did it because I had the cosecant that way also. And there's my answer. Cosecant, cotangent do not simplify. Cotangent is cosine over sine. Cosecant is 1 over sine. So they don't simplify. There's number 7. Number 8. Then y equals cosecant x over x negative x and 2/3. You can either do product rule or you can do quotient rule. It actually does not matter. You look it up again, so they just will look different. I'm doing quotient rule. Low behind root cosecant is negative cosecant cotangent minus high below 2/3 x to the negative 1/3 all over low x to the 2/3 1 squared negative x to the 2/3 cosecant x cotangent x minus 2/3 x to the negative 1/3 cosecant x all over x to the 4/3. This is what's called a complex fraction because I have fractions within fractions and I have negative exponents, so that's going to be an issue. What I am going to do is I am going to simplify, and I'm going to take out. I'm going to do it 2 different ways to show you 2 different ways that I can simplify this. The first thing is because the denominator is a single piece, I can split it and write it in 2 separate pieces. If you left it in blue, you would not get full credit because you have a fraction within a fraction. You can't do that. I can simplify these 2. That's going to give me negative cosecant x cotangent x over x to the 2/3 minus this is 2/3 x negative 1/3 x over x 4/3. I can simplify these two. That gives me x to the 5/3. Go secant x. This 2 goes on the top, but 3 goes on the bottom. Here's one simplification of this. Here is the other simplification. And I think black is the actual easier one to do than the one I'm going to do next. Just because of that 2/3. I'm going to multiply everything by 3 to get rid of that denominator. So this is going to be a negative 3x to the 2/3 cosecant x cotangent x minus 2x to the negative 1/3 cosecant x all over x to the 4/3 over 3 because I multiplied top and bottom by 3. I multiplied every single piece by 3. That took care of my denominator of my fraction. Now to take care of my exponent, it does not go down, the negative does not go down here because there's a minus sign right there. What I am going to do is I'm going to factor out a negative 1/3. I'm going to factor out x to the negative 1/3. That leaves me with 3x. Just plain old x, because if I factor out negative 1/3 out of 2/3, that gives me positive 3/3, and 3/3 is 1. Think about it if you distribute. 1 plus negative 1/3 is 2/3. Cosecant x, cotangent x, minus 2 cosecant x, all over 3x to the 4/3. And now I can bring that down. Now I can bring it down. Negative 3x cosecant x, cotangent x, minus 2 cosecant x, over 3x to the 5/3. Here's my other answer that you can give me. Again, the black and the red are actually the exact same answers. It's just they don't have a common denominator. And if you put them back in there, you wouldn't have a common denominator for black. So that's my final answer for this one. And my last one is number 9. Secant x over 1 plus tangent x. Again, quotient rule. Low, be high, get rid of secant x and secant x tangent x. Minus high, tangent x and secant cubed squared x. Over 1 plus tangent x squared. That gives you secant x tangent x plus secant x tangent squared x minus secant cubed x all over 1 plus tangent x. Quantity squared. Oh look, they all have a secant in common, so I'm going to take that out. That gives you tangent x plus tangent squared x minus secant squared x. 1 plus tangent x, quantity squared. Oops, sorry about that. A reminder, ladies and gentlemen, that over here we had this tangent squared x plus 1 equals secant squared x as one of my Pythagorean identities. Remember that? That's one of those Pythagorean identities, tangent squared plus 1 equals secant squared. Which means this secant squared right here can be tangent squared plus 1. So I have secant x, tangent x plus, tangent squared x minus, tangent squared x plus 1, all over 1 plus tangent x, quantity squared. And oh look, that gives me secant x, tangent x plus tangent squared x minus tangent squared x minus 1, wait. Those cancel out. And I'm left with secant x is tangent x minus 1 times 1 plus tangent x 1 squared. There's my final answer. So again, it takes a little bit more work and a little bit more practice, but it is exactly the same problems. Exactly the same rules. Okay, we have 2 more problems if I am correct. Yeah, the last 2 problems that we're going to do. And here they go. Find the equations of the tangent line and the normal line to x plus f of x at x equals 0. And I am going to, yeah, that's fine. So here we go. If I want tangent line and normal line, again, y minus y1 equals m times x minus x1, I need the derivative. So f prime of x, the derivative of x is 1. The derivative of cosine x is sine. By 1 minus sine x. I need to evaluate this at x equals 0. That's 1 minus the sine of 0. The question is, do you know what the sine of 0 is? The sine of 0 is 0. That's 1. Let's talk about what f of 0 is. F of 0 is 0 plus the cosine of 0. The cosine of 0 is 1. F of 0 is 1. This is f prime over here. So, tangent line. Y minus 1 equals 1 times x minus 0. Normal. Y minus 1 equals, it is the opposite reciprocal of this, negative 1, x minus 0. You don't have to write x minus 0, you can just write x, that's fine. I wrote it there so you can see where things were going. There's my equations of tangent lines and normal lines. Oh wait, that means you need to know what the cosine of 0 is and the sine of 0. Yes, you need to know the major parts. Your pi's over 4s, pi's over 6s, pi's over 3s, pi's over 2s, pi's. Your unit circle from last year. Particle number 11, the last question that we have. Particle moves along a line so that any time t is greater than 0 is given by the function x of t equals 2t plus cosine t. Find the velocity. So if you remember, x prime of t equals v of t. Find the velocity at time t, so you're finding the derivative of this. The derivative of this is 2, plus the derivative of cosine is negative sine. It's plain old t, so there we go. That's 2 minus sine of t. There we go. To find the speed. To find the speed, that means that I take my velocity, it is the absolute value of the velocity, at t equals pi over 2. So, the absolute value of 2 minus the sine of pi over 2. The sine of pi over 2 is one of the ones that you should know. It is 1. So my speed is 1 units per second, or whatever the units are. Find the values for which the particle is at rest. If the particle is at rest, that means that v of t has to equal 0. Where does v of t equal 0? Well, there's my v of t. So 2 minus the sine of t has to equal 0. That means that sine of t has to equal 2. Well, I have a question for you. For what angle does sine equal 2? If you remember, how high does sine go and how low does sine go? Here's a reminder of what the sine graph looks like. Does the sine graph ever go to 2? Or does it never goes to 2? So, find the values. None. None. There are no values. Never true. Never true. There are no values for which that is true. So, those are the ends of the notes. You are going to work on your homework at this point in time.